All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Got a couple of different things tonight to kind of go through and talk about. But before we do, I just want to go ahead and take a moment and say a quick thank you to our supporters of the channel, beginning with our partners who are the highest tier of subscription over on Patreon and YouTube memberships. They are Dustin Punt, Gabby Bashir, and Gerboles Inc. I would also like to take a minute to thank all the other supporters listed here on the screen. They are a combination of Twitch subscribers, the other tiers of support on Patreon and YouTube memberships. So thank you all very much for your support. It is greatly appreciated. That being said, without each and every one of you viewers here on the YouTube side and over on the Twitch side, this project would not exist. So thank you all very much for being here. I appreciate you guys as well. That all being said, this is an interactive stream. We do simulcast to YouTube and Twitch, so I do keep an eye on both chats. I've got them open on separate screens here. So anyway, so speaking of chats, let me go ahead and catch up with the chats that are here. Apotham and RCW, thank you very much for the Tier 1 and Prime subs. I really appreciate that. Thank you very much. That support means a lot to me. That's very kind of you. I was official. Good evening. How are you? I am doing well, by the way. Thank you for asking. Yeah, tonight we've got a little bit more refactoring work going on, but this is going to be stuff that's going to pay off in a big way. So what I'll do is I'll catch us up as to where we left off last time. I did a little bit of stuff off screen as well, and we'll kind of pick up from there. But we're doing a lot of work and preparing for, starting to make a game, right? So we want to make things a little bit more configurable. We need to batten down the hatches on some things. And unfortunately, that does mean we're going to have to move some stuff around and refactor, and it's just kind of a necessity, right? So part of the purpose of this is just to show some of that work that's being done. So I try to showcase a little bit of that on here as we go through. All right. So with that being said, what we are currently working on is we are working on building out a application config that is in a JSON file that looks like this guy. So we've got our basic high level properties like our application name, our frame allocator size, our app frame data, things like that, right? And then we've got some additional properties down here. I'll come back to these plugin names in just a second. So the next thing we have is a configuration of windows that can be an array. So another thing that we're adding at least partial support for right now is multi-windowing. We're going to probably need that for our editor. And there's some things that are tied to the main instance of the application that really should be tied to a window instead. So we're going to be kind of refactoring a little bit in our renderer to make that happen. And we may not support multiple windows right away. But we do need to start thinking about that. So we are going to be moving some things around so at least this configuration works. So when we set these up, we have the ability to set a starting resolution, a starting position, an internal name for the window so that we can reference it by name, and then also a configurable title, right? So this allows us to set all this stuff up without having to rebuild the engine, essentially. Let's see. Love what you do. Oh, I appreciate that, RCW. Thank you. And so the biggest portion of this is this sort of systems array here. So we have all of this. If I go over here to the engine, we have all these different systems all the way down that sort of have these hard-coded configs. And we have lots of to-dos saying, hey, we should be... the application should be able to configure this, right? We've got several of those to-dos in here, and some of them that don't have them that probably should. And so this is going to give us the flexibility to set all of those things in this file once we get there, right? So our systems is basically just an array, right? And within that, we have an array of objects, or a list of objects. And then within each one of those, we have a name, which in this case is going to tell us what system we're currently configuring in this. And then all the other properties of that are going to be properties of that given system. So, for instance, this is the plugin system that we're currently configuring right now, which doesn't have a hard-coded config. This is going to be sort of the first litmus test of this, right? And so what this has is an array of plugins, and those plugins are being converted to a standard plugin interface that we're using. And that standard plugin interface defines a couple of things at the top level. So it defines a name of the plugin, which is kind of following a standard naming convention that we've recently defined. So this one is a kohi plugin, right, of the type renderer. So it's a renderer plugin, and then it's the Vulkan renderer plugin, right? So by the name, we can kind of tell what its use is and a little bit about it, right? And then within that, it's also going to have its own configuration with properties in here, right? And so we've got that, and we also have. Hang on 1 second. Somebody's whispering me saying I don't have. Yeah, YouTube should be up. Can you guys over on YouTube see and hear me? I see the. I do see the connection is there. It should be there. We should be good. Weird. Okay. Yeah, I'm not sure. Sometimes YouTube's a little bit buggy. Okay. Anyway. Okay, they see it now. Perfect. All right. So we have all these individual plugins, which right now the configuration's empty. We'll figure these out. We'll fill these out one by one, right? So we have one for each of these plugins that we have defined. We have one for the audio plugin, one for the UI, the standard UI plugin. And all of our other systems will be configured this way as well. And so basically the way this works is we have a application configuration that loads up this sort of base structure here. And it keeps a hold of these sort of globally defined properties here, and then also a list of system configurations, which each hold on to their own. And at each level of this, those things are essentially handed a string of their configuration. So, for example, in the systems, when we're defining the plugin system, everything from this plugins array and any other property is handed, the plugin system itself is handed basically this section of the document as a string, and then it's up to that to deserialize it. When the plugin system is going through each of the individual plugins, it says, okay, it's going to basically take each one of these config sections and hand that off to each one of these plugins as a string, right? And the benefit to that is we don't have to worry about parsing all that stuff out at the top level and trying to understand it there. It's up to each of the plugins to parse things or not, depending on what have you, right? In some cases, we may have a plugin that doesn't have configuration at all. We just basically have to say, hey, this exists, load it. And so our UI, our standard UI may wind up being that way, so that I just have that there as an example. And so that's more or less what we're working towards right now, in addition to the plugin refactor itself, right? So these things kind of go hand in hand, so I figured we might as well bite the bullet and kind of handle this now. Magetz, how's it going? Good to see you. Welcome to the stream. Good to see you here. All right, so with all of that said, where I left off was I've actually done a lot of the work behind parsing the plugin systems deserialization. So we've already got all that stuff in place. So if we go up here, The way this essentially works when we load all of this stuff in is actually if we go to entry.h, and we go to where our main function is, the first thing that we do is we load up the app config JSON file that we just looked at, right? So that is here. Let me make sure I'm not coding behind my head here. Yep, we're good. Okay. So we load up this file here, and we essentially load that as a string, right? We make sure that we have that, and then we pass it off to this application config parse file content, which is essentially a deserialization routine for this, which actually, I have an empty string there. That should be app file content, right? And so basically, if it fails that, it's going to bleat about it and throw an error. And so what this is going to do is it's going to take that configuration file that we have, and it's going to deserialize it, if I can talk tonight, into this app config right here, right? And so from there, we can go ahead and create application, let the application do its thing, come down here to engine create. Some of these function pointer checks are going to be changing as well, because we're going to change the way that that stuff is loaded too, but we'll tackle that as in a separate pass. And from there, we come over here to engine create, and pretty much, let's see, immediately after we sort of set up our memory system and some of our basic settings, we go ahead and begin our platform initialization, which actually has some configuration that we need to read in and so forth. And so what we're going to have to do, and like I said, I've started with the plugin system, is we're going to have to convert each one of these systems to deserialize its own configuration. So the example of this that I've got so far is for our plugin system, because that's where I'm starting. And so the plugin system basically just has this sort of generic system config, right? And this structure essentially just has the name and some configuration in it, right? And so what we do here is we say application config, system config get, right? And this essentially loops through that array that we have in the JSON file. So this loops through this array of systems and says, all right, give me something whose name matches, right? So in this case, plugin system is the only one we have. And so we are looking for plugin system, right? And so it just writes that to our configuration object here. And obviously we make sure that we get it and so forth. And then we say, okay, plugin system deserialize config. So what it does is it takes that configuration string that it's been, that was extracted when we were reading in the app config, and it says, okay, take in that string and write it to this plugin system config. So this is that object that we set up before. And so if we go to plugin system, it fills out this guy right here, which our plugin system config just has an array of plugins. Each one of these plugins has a name and its own configuration string, right? So it goes ahead and deserializes that, initializes the plugin system with that configuration, and then we're good, right? And then from then on, anything that needs that plugin, we can then reference that plugin and get it by name from the plugin system. So I hope that all makes sense. I know there's quite a lot there. There's quite a lot of moving pieces. But unfortunately, with something like this, a change of this scope, there's kind of not really a way to do it other than kind of all at once, right? All right. Trog, how's it going? Good to see you. Welcome to the stream. Okay, so let's see. I don't even remember. Okay, we were in the renderer actually. We were in the renderer actually reworking, starting to rework how that plugin is going to interface. Okay. So, one other thing I should point out. I don't think I pointed this out when I started the stream. I am finally back on Linux. Arch, by the way. I tried for quite a while to get Pop! OS to work the way that I wanted because I wanted to try something different. And finally, I'm like, you know what? Screw it. Well, I'm just going to go back to Arch, right? And I tried to get Pop! OS to work the way I wanted for about, I don't know, week and a half, 2 weeks, something like that. And I was able to set up Arch in like less than 2 hours and get it up and running, right? So back on Arch, by the way, which is also why everything builds so fast, right? Bam. Super quick. All right, so let's go over to the renderer front end and talk a little bit about what we're doing in here, right? Because there's all kinds of stuff that we need to do in here. In fact, let's go over here. We'll close this guy for now. And we'll talk a little bit about the renderer and how that's going to change. So we used to have this thing called a renderer plugin. And the renderer plugin is in render types, plugin, if I can spell it right, plugin, jeez. Okay, so here we go. So this is the renderer plugin, which this is going to get renamed. And this is basically our interface point into our renderer backend, right? So we had this named renderer backend at one point. It is now going to be renamed to renderer backend. And we even have here in the comment, it's a generic interface, right? So this is essentially what we're going to rework. And so let's see, our renderer backend is now going to have this K runtime plugin, which is loaded by our plugin system. And we're going to use that to get to the sort of generic level plugin. And then that plugin itself will be responsible for sort of implementing this interface, for lack of a better term, right? And that's what we're going to call the backend, right? And so I'm thinking about like renderer backend interface, maybe, or something of the like, in order to actually to get what we need there. And so that's essentially going to be renamed. The renderer plugin or the backend is also going to be kept by the backend plugin itself. It's actually going to be owned by this thing. So what we're essentially going to do is we're going to get the render system state, go to the backend plugin, and then get the backend, right? Instead of having just this here. I might keep a convenience pointer just to keep things from being too verbose. I haven't really decided yet. But that's kind of where I left off in terms of what we were actually reworking. So essentially the way that this works is we get our engine systems list, right? And we say, hey, our backend plugin is plugin system get, right? And we pass it the plugin system state. And then we go ahead and we get the configs plugin name. So the configs plugin name is going to be the renderer plugin name. So if we go back to engine and we go to the renderer system, the plugin name is now a duplicate of game instance application config renderer plugin name. So that was the global property that we saw up here, right? So it's just going to get that and use that to actually load up the plugin. Okay. So once we have that, then we need to start converting everything to use the backend plugin internal state, right? And that's kind of where I left off. So I hope all of that makes sense. Let's see. All right. So my first thought is we have this renderer plugin, right? All right, well, the good news is we don't actually use that structure name anywhere here, other than right there. So we don't have to refactor a lot in terms of that. So maybe we'll call this, instead of renderer plugin, we'll say render backend interface, I think is what we're going to rename that to. So we'll do renderer types. Do the top here. So we're going to rename this to renderer backend interface. That seems kind of long. I think that's fine, right? And let's go down here, and we will also render backend interface. And I'm specifically not doing a global rename on this because I want to get specific errors on all the places that this is used so I can make sure that the usage is correct, right? So we've renamed it here within this struct, which is fine. That's exactly what we want. But outside of that, we should not have it renamed, right? So essentially, the way this is going to work is if we take a look at the kruntime plugin. The kruntime plugin has a few different things. It's got the name, the dynamic library, and then a bunch of function pointers, and then the kruntime plugin state. Kruntime plugin state, I believe, was something that we just kind of put into place to hold a type, like an opaque handle. I'm now thinking that's going to be a different type for each one of these. So this is one of those places I am actually going to stick with a void pointer. Right, and the reason I'm going to do that is so that we can safely typecast it, right? Because it'll be confusing if we have sort of two different structure names there. We don't want to do that. We don't want to be bound to that. And we may have some of those things that'll be public and some of them that'll be private. And we don't really want to have multiple definitions of the same thing. That would be terrible and bad. So essentially, this renderer plugin is going to be a cold cast. What did we call that? That was renderer backend interface, right? Is going to be a cold cast of the kruntime plugin state, right? So we're actually going to say interface to the backend plugin. This is a cold cast from backend plugin plugin state, right? All right. So what that means is what I was beginning to think about here, state backend is equal to the plugin state cold casted, right? So this is going to be renderer backend interface pointer, right? Cold cast to the known type and keep a convenience pointer, right? So we can still say state backend, but really it's the state backend plugin state. What's a cold cast? Sounds like a blacksmithing term. Yeah, cold cast is basically just directly casting something like this, right? So it's just saying this is the actual type we want to use. It's just a cast, C-style cast, right? And I use that to differentiate it from, C++, all the different style casts you have for C++, right? Cold cast is me literally saying, hey, this says it's a void pointer, right? We are literally just telling it this is absolutely a renderer backend interface at this point. We're code blacksmithing is what we're doing. Hey, followed your tutorial, stuck at making Clang work. Do you have a Visual Studio installation? Do you have to have a Visual Studio installation to make it work? For Windows, yes, you do. And incidentally, I think you have to have... I don't know that this was always true, but I've had several reports of people telling me that you have to have Visual Studio installed first and then install Clang. So if you have Clang installed, uninstall it, install Visual Studio first with the C compiler, then install Clang. I hope that makes sense. And first time chat, welcome, by the way. From Lake, good evening. How's it going? Good to see you. Cry, also good to see you. What would you say some things Vulkan has streamlined from OpenGL? That depends on your definition of streamlined. In terms of API usage, nothing. Vulkan's much more verbose, right? I wouldn't say it's streamlined at all in terms of API use or, verbosity or anything like that. It does give you a heck of a lot more control over everything. In fact, it forces you to take control of that stuff. So you have to be very mindful about memory layout and things like that, even more so than you ever had to be with OpenGL. Okay. Default frame buffer size. I'm okay with keeping that hard-coded in there because we immediately change it when we resize anyway. State plugin, config plugin. We don't need that anymore. Okay. So a lot of things that are going to be state plugin are going to wind up being state backend. And I think it's literally going to be a lot of find and replace behind that. Okay, so renderer backend config. So this is where it gets a little bit interesting. So we have a to-do here. Expose this to the application to configure, right? Make this configurable. Renderer backend create. So I don't think we actually need... We don't need this anymore. That's just a reasonable default. Renderer config application name. So that's basically fed back into like when we're setting up the app info in the Vulkan plugin. That's essentially what that's doing. We really don't need... I don't think we need that anymore. Some of these flags we probably ought to take in, right? And so we probably ought to... We ought to think about some of these things in terms of configuration, right? So there's actually going to be some stuff we need to think about in our configuration file. So let's actually open that back up. And let's have a look at this, right? So we've got, we have our Vulkan plugin here, which is all the Vulkan specific stuff that we need to pass, right? But these properties here that we're looking at on the left, these are more specific to, I mean, they're kind of configured by the front end and passed over to the back end, right? So all of these things are generic enough where they're sort of front-end configuration, and then that gets just passed through. So we really should configure this on the front end, not the back end. And then maybe we can query the front end from the back end to get those things instead of like passing through a back end configuration. Maybe, right? So what I mean by that is, we're going to have ads here in just a second. What I mean by that is we've got our backend here, right? So this is our renderer backend, our configuration for that. But we really need to have like a separate system configuration here for our renderer as well. So we're going to wind up with, something like this, right? Where we have name equals renderer, etc. Right? We are going to have ads here in a second, so I do like to pause the stream whenever we have ads. We're served ads once every 30 minutes for 90 seconds or up to 90 seconds on the Twitch side. So to level the playing field, I like to just pause the stream so that nobody misses content, right? So it's a minute and a half. I urge you guys to use that time to go get water and stuff. We put a timer up on the screen so that you guys know exactly when we're coming back, right? So those ads are going to be kicking off here in just a moment. And so we like to pause the stream for that purpose. So before I continue with this, let's just wait for those ads, and then we'll handle that on the other side of the ads. Let's see. Shouldn't need Visual Studio, you just need the VC runtime tools. That is true. We have ads. I will answer the second part of that after ads. All right. Got about 20 seconds left on ads. All right, and ads are dead. So yeah, just a footnote about the whole Visual Studio thing on Windows. Yeah, technically speaking, you don't need the whole Visual Studio. I usually just say that because it's quicker and easier for most folks to just install the whole thing. Technically, you only need a part of it, right? So you just need the C++ Clang tools for Windows and the VS installer, and that should be enough, right? But yeah, usually versus explaining that, I usually just say to install Visual Studio. I probably am going to wind up doing like a small update / patch video to just kind of put in the series. Just to kind of put that in there as a footnote, because that was actually recorded 3 years ago. So, let's see. Why do engines usually make character animations such as humans keyframed instead of kinematically or physically solved? So they don't necessarily anymore. Keyframed is sort of the classic way of doing it, and there is still there's still a lot of that, right? But a lot of times these days it's kind of a blend of those things. Like when a character ragdolls, that's physically solved. Using inverse kinematics is also a pretty popular thing in terms of defining like a range of motion, like when you're moving a gun around, like what the arms can do and how they respond to various types of movement, right? It's usually a blend of those things, so it's not usually just keyframed anymore. Is it because there isn't a good general solving method to calculate biomechanical movement of a human, or is it because it's too computationally expensive? So, usually people don't go to that level just because it's generally not worth it for the result. It's generally it's what you're doing is simulating it, right? Which a simulation is generally a very simplified model of what happens in the real world, right? So, you don't simulate the way that muscles and stuff work typically. Some engines do it, right? But generally speaking, you simulate a bone that's nothing more than essentially a rotation and maybe a line, like an invisible line, but that's about it, right? What code editor are you using? Sorry if this is a dumb question. I'm new to programming. So there are no dumb questions here. The only dumb question is the one that you don't ask, right? So I encourage questions. So never feel like it's bad to ask a question. I'll always answer them to the best of my ability. I am using NeoVim, and I actually have, I'll drop a link here in the chat, actually on both sides. A link to my specific setup and all of the various things that I have configured for NeoVim. I actually wrote an article on my website that explains all of it. You're referring more to the third-person animations such as running, walking, jumping. Yeah. So there's a lot of times it's a blend between those things, right? It's a blend between physics reactions, like maybe somebody's foot pivoting over uneven terrain or something like that, so that you'll have that blended with a keyframe animation of the person walking, which is normally taken from like motion capture or something like that in high-end studios, and so it's usually a blend of those things these days. So I hope that makes sense. All right. Oh, looks like my bot on the Twitch side did not drop the link. Okay. I think Streamlabs bot is acting up tonight. That's always fun. Just think the old way of doing third-person animations are always laborious due to blending animations. Now motion matching is better, but it isn't perfect. Yeah, exactly. It's just different techniques to the same thing. And it also is a factor of budget, right? Because mocap is pretty expensive. And not every studio can afford to do that, right? I'm certainly not going to be able to afford to do that with the games I'm going to make. So it's a matter of the tools you have at your disposal too. Okay, so we were talking about systems, right? So we have, is my tabbing off here? It is off. Why? I really need to make an LSP for KSON one of these days. But anyway, because an LSP would allow me to auto format as well. All right, so we have the name of the renderer, right? And then we can define some of these sort of front-end specific properties, right? So internally, we have these sort of render flags, right? But in terms of configuration, we can just use Booleans for those things. So we can say, vsync equals true, right? We can do, let's see, what was the other thing we had here? Power saving bit, right? So equals true, which that just changes some of our Vulkan settings for right now. We may wind up not using that for some backends, and some backends it does something, right? We can also say enable validation, right? We want to set that to true. And so all of those things, there's no reason that they can't just be sort of generically configured on the front end. And so I know this says render backend config. That's a little bit of a misnomer. But we can actually, I guess, pass this in, for lack of a better term, to our renderer front end, keep it there, and then maybe we'll find a way to either pass these through or query the front end for these things, right? Because we probably are going to need to check them from time to time anyway. You hate seeing some foot sliding or movements that aren't physically accurate, and motion matching doesn't solve that. Yep, exactly. There are some engines out there that put a lot of work into doing that, but yeah, it is a lot of work. Just blows my mind that big studios haven't invested time to find a general solution for those movements to cut out work when making animation. So some studios have, though. I can't think of an example off the top of my head that's perfect, but what was actually, I think, was it Horizon Zero Dawn? I think it was Horizon Zero Dawn that they did a lot of work behind that, if I remember correctly. There are studios definitely that have addressed that. I know I've watched talks on it. For sure, that's been something that's been addressed. But most of the solutions to that are proprietary, right? Like a studio is going to make those solutions, and they're not going to release that code to the public. No way. It costs them way too much money to get it to work right. They're not just going to release that for free. All right. So we have some of these properties like this. I think, let's see. What are some other things in here that we probably need to pick out? Yeah, I'll see if I can. I'll have to see if I can locate the talk. But yeah, there was, and I don't remember if I might have the game wrong too. But yeah, there's definitely stuff out there on it for sure. Okay. Plugin initialize. Okay, so this is where we get into initializing the backend. And some of this stuff is going to have to change too, because some of this stuff is tightly coupled to window creation, and it should not be. We also do some creation of buffers here, which I'm not going to have be configurable because I think we're going to move those around. So that I'm probably going to skip and or leave this configurable for now. Along with like the naming and stuff like that, right? When we come up with a final solution for this, we might make that configurable as well. But for right now, I'm not going to worry about it. So looks like the most important things we need are these individual properties, right? Which we should probably think about. Yeah, that should be fine in terms of naming. Vsync. So actually, yeah, it's really just those properties as far as I can tell. All right. So for right now, that'll work. I think we've got some stuff on the Vulkan backend that we need to configure as well. But for right now, our configuration on there is empty. Okay. So let's go ahead, and we actually have a renderer system config. So where is that defined? I think that's here. So right now we have the application name and the plugin name, which is actually kind of handed to us up here. And that's actually kind of wrong now that I think about it, right? That probably shouldn't be a global property. That should probably exist down here, right? So let's actually take this. We'll probably do the same thing for the audio system when we get it. So let's say, let's just say plugin name. Or should we say maybe backend plugin name, right? We'll use backend plugin name. So we'll do constant character array backend plugin. What is with my typing tonight? Name. And then we'll do, we'll split these things out into booleans. Right, and then we can collapse them into flags when we initialize. So we'll do B8. Let's do vsync. Right, and then B8 enable validation. And then we'll do B8, what was the other one? Power saving. Right? And so we'll need to actually set up another function here to interpret this configuration. So we'll do KAPI. Actually, no, we don't need to export this one. We can just say, we'll do B8 renderer system deserialize config. All right, And we'll do constant character array. And I think we're going to call this config string. And then we'll do a renderer system config pointer out config. Right? And so we'll use this to read in the JSON and parse out these properties, use defaults if we don't have any of them. The only one that I think that's going to be required is going to be this backend plugin name, right? If we don't have that, we can't do anything. But the rest of these, we could reasonably default those to true or false or whatever. So we have application name, plugin name. I'm going to do away with that. And I'm going to take this, go over to front end C, and we're going to put this right at the top. Right? And first thing we're going to check is if we don't have config string, right? Oops. If we don't have config string, or we don't have out config, we're going to bleat about it, and we're going to say renderer system deserialized config requires a valid pointer to out config and config string, right? And return false. And so this may not necessarily always be the case for systems that don't require configuration, but this does require configuration because there is a property there that is non-optional and it will not know how to resolve without it, right? So the first thing that we're going to do is we're going to create a JSON tree, and that should import the or include the library that we need automatically. We're going to call this tree. Let's just initialize that to 0, right? And we're going to do if not JSON from string, tree from string rather. We're going to pass to the source. We're going to say config string. And then the tree itself is going to be the address of tree, right? And if that fails, we're going to say k-error failed to parse renderer system config. Return false. Right? And then once we have that, it should just be a matter of actually extracting the properties that we need into our out config. So the very first thing we're going to do is we're going to say backend plugin name is required. Right? So we're going to say if, actually, I need a string for this. So yeah, if not JSON object value get string. We want to pass the object. We're going to say the address of tree root, right? That's the root object that we're passed. The name of the object we are looking for is going to be backend plugin name. And notice we have a double pointer here, right? So this is a pointer to a string or a constant string. And what this is going to do is it's going to allocate memory for us, so we don't have to worry about that. So what we'll do is we'll say we're going to pass the address of out config backend plugin name, right? And if that fails, then we're going to do a k-error and say renderer system deserialized config. And then I guess we'll say config does not contain backend plugin name, which is required. Return false. Right? And so that's the only one that's required. If we don't have that, we absolutely can't continue, because we can't always just assume we're going to use the Vulkan plugin, because we're going to have others, right? So this is just saying which one we want to use. All of the other ones can actually have defaults, right? So in this case, we can say if not JSON object property, JSON object value Boolean, or get Boolean rather. We want to extract this from the tree root, so the address of tree.root. The name of this one, we'll go ahead and do, let's see, we'll do them in the order that we define them in the structure. So we'll do vsync first, right? And we want to extract that to the address of outconfig, outconfig vsync, right? And if that does not exist, default to true if not defined, right? So all we do is outconfig .vsync equals true, right? That way, if it's not found, we just fall back. Oh, Riche, thank you for the stretch redeem. I need that. Smudge, you've got 2 really good talks about that topic. That's awesome. Actually, if you don't mind, if you have links to those, would you mind dropping those in the Discord in the Kohi channel? Yeah, that would be awesome, because I think that would be a useful resource. I know I watched at least one of them at one point, but I don't remember how long ago that was. Let's see, is the Discord should work. Yep, there it is. Okay. Yeah, the bot is a little slow tonight, but it looks like it's working. So, okay. So we have the one for vsync. So we're just gonna copy pasta this a couple times. So we're gonna do vsync. We'll do enable validation, right? And by default, we're gonna enable validation, right? So we'll do that. And then, what was the last one? Power saving. Right, we'll do that one too. That one's going to be particularly important when we do mobile. Okay, so now that we have our optional properties done, and we've actually deserialized everything that we need to deserialize, we can now say JSON tree cleanup. We don't need it anymore, so we can say address of tree. And then we do want to keep like all the strings and stuff we've generated, so that's fine. We'll go ahead and I don't think there's anything else we need to do, so we can actually just return true at this point, right? And that is our renderer system deserialization, right? So we basically just repeat this process for each of the systems that have configuration in this manner. And this is how we will get the data that we need, right? So before we forget, let's head over to the engine and just make sure that that is in place, right? And we're going to essentially follow, this model, right? So, yep. So let's go to the renderer system. And we're going to get the generic config from application config first. So instead of plugin system, we are going to get renderer, right? No configuration exists in app config for the renderer system, this configuration is required, right? So if we don't have that configuration, that's a hard fail. And then we'll do, we can get rid of this, take this, put it up here, renderer system config. So we can do renderer system config, and then this is going to be renderer system deserialize config, right? Failed to deserialize renderer system config, which is required. Okay, so we're not going to fill this configuration out manually anymore. Right? We also need to head over to our application config, because we did change something there that we now need to remove. Let's see, did we actually put the application config here? Yeah, here we go. Okay, so we don't need this guy anymore. Right, that's the configuration for the renderer plugin name. So application config C renderer plugin name. Let's get rid of that. Don't need that. All right. And then we can go back to engine, which I think should be good now. Okay. All right. So back to renderer front end. So we should have everything we need at this point from parse out of our configuration. Now we need to actually apply that here. And so let's see, we have our renderer config. I suppose what we could do is just pass these properties through for now with a fix me. And we'll say have the backend query the front end for these properties instead. Right. We can get rid of that. We can get rid of that. These things are going to be fully powered by our configuration now. So we have the application name, we have the renderer config. Oh, this is renderer backend config. Let me think about this for a second. So the only thing that this takes in is flags, right? So we need to actually process our booleans and say if. Let's start with renderer config flags. We'll start that off with 0, right? And then we'll say if config Dev, thank you for the follow. Appreciate that. Welcome. And thank you so much for posting those on the Discord. Appreciate that. So we'll say config. We'll do vsync first. So if vsync is set, then we're going to do renderer config flags or equals. And then we'll do this flag right here. Right? And we'll just kind of repeat this same thing a couple more times. Right? So if we have validation enabled, or enable validation, I guess. Config flag enable validation. And then what was the last one? Power saving. So if power saving is on, we'll say power saving bit, right? So we can get rid of these guys. And now that's completely powered by our application config. Okay. So state plugin does not exist anymore. That's going to be backend, right? So we replace those. Okay. Now we do know we're going to have to do some additional work around this initialization routine, but we'll come back to that. All right. Setting up the buffers and stuff, we said we're going to bypass that for right now. What is this bleating about though? Oh, right. We did away with state pointer in here because now instead of passing a void pointer as the state here, we actually pass a render system state, right? So because we have that, we don't need all that cold casting anymore. We could just use a state directly from here, at least for this, since it's provided as an argument. Backend plugin system gets config plugin name. This is backend plugin name. Okay. So I think that should be good for that. The shutdown is going to be backend shutdown passing through the backend. Resized is going to be... Ooh, you know what? This is going to be a problem too. Because this needs to take a window, right? This is Windows specific logic now. So we're actually going to have to open up handle resize events, right? We're going to have to know what window was actually resized, right? So this is going to be k window. Window. You know what? We probably could just forward declare that, I suppose. Yeah, we can just forward declare that. That's fine. Struct k window. Okay. Window, the window that was resized. We made that change at the engine level. We haven't made that change at the renderer level yet. So we'll need to do that. So this needs to also take in struct k window. All right. Which means that our state pointer frame buffer width and height thing is going to have to change too, because we can't just have one of those. We've got multiples now, potentially. Okay. Roman General, good to see you. Hello. Thank you for stopping by. I know you're an anti-Windows warrior, but do you have experience with DirectX? Yes, I do. I have not used DirectX 12 yet, but I have used DirectX 9, 10, and a little bit of 11. So I am going to be making a DirectX rendering backend for this engine, though. So yeah, like I don't always like to use Windows, right? But I do recognize that it is a it's the market leader right now in terms of gaming, right? So I can't not support it. So that's going to be actually the next renderer backend that I do. Is probably going to be that one. And then I'm also going to do Metal for Mac OS so that we have native support for that. But yes, we are going to be handling that. And I am going to be using DirectX 12. So when I go to do DirectX 12 and Metal, I'm going to be learning the API as I do it, which is going to be interesting. It'll be interesting to see how that works, because I've never used DirectX 12 and I've never used Metal before. So that's going to be an interesting exercise for sure. All right. So the current window frame buffer width. So this is going to actually require these two guys are going to have to be separated into like window specific information. So our renderer state is actually going to have to be expanded. And I'm doing this now because I need to track it, right? Or otherwise I'm going to lose track of it. So let's type def, a new structure. And we're going to call this renderer window state. Renderer window state. All right, and this is just going to be internal to the renderer. There's no reason for anything outside the renderer to be aware of it. It is going to hold a struct k window, right? So the window it's associated with. It's going to hold the frame buffer width and height for that particular window. And actually, it might actually have to hold a viewport too per window. That's a really interesting idea too. Right, because each window is going to have like separate viewport information, right? Because its rectangle is going to be assumed to be different, right? Which will mean that its projection matrix will have to be different, and so forth. So we may have to rethink how we handle viewports a little bit. Viewport, active viewport. Where is... I don't think this is used all that much. 5 times. We set an active viewport. So that gets passed off to the plugin. So the plugin is probably what uses it the most. In fact, it's just to get it is literally just to pass through the backend. So that's going to be interesting. I'm going to move this here as well. Right? The viewport information for the given window. I think that makes sense. Nolagor, first time chat. Welcome. How's it going? Thank you for the follow, by the way. I appreciate that. Welcome to the stream. Okay. So down here, we have window render target count. So that's an interesting thing too. So that's associated with the number of Swapchain images. Theoretically, we could configure one window to double buffer and another window to triple buffer. Or one window to vsync and another window to not vsync. Do I want to screw with that, or do I want to just say the same setting across the board? I think I'm going to say the same setting across the board. No matter how many windows we have. Yeah. I think that's what we're going to do. All right, so I'm not going to worry about that for right now. Window render target count, though. Should I still make that per window? Just, you know what? I'm going to, because each window is going to have its own like swap chain. So we're technically going to need like different render targets per window. Okay. So I guess the next thing that we need is we need a quick way we need a quick way to look up a window state by its pointer, right? Now we're never going to have like a huge number of windows, right? So it's not like something that has to be looked up stupid fast, I don't think. But it is something that we're going to have to like loop through and potentially do multiple times per frame. So I'm thinking the number of lookups for that should be, like the lookup process for that should be as fast as possible. The only thing I can think of is maybe we have a lookup table where the window pointer is the key, right? So we use that as the key. And then we use the value would be an index into an array of window states. I don't even know if it's worth doing all that though. Thing is, we don't have like any sort of structure that would really work very well for that, I don't think. And I don't want to make one just for that. Maybe I'll just do it the naive way for now. I'll make a D array of them. And if we need if like it comes out to be like a performance bottleneck or something like that, we can reinvestigate it later. So we'll say render window state, window states, right? And then in the initialize, I guess, right? We're probably gonna have to set this up pretty early on. We're gonna have to say states window states equals darray create. And the type we're gonna use is gonna be renderer window state. And then these things are not going to be able to stay here. Those are going to have to be like when we create the new window. So did we ever have platform window create? Do we have a way of actually getting the size of a window? I don't think we do. Like we can get and set the title. We do have a window resize callback. So, all right, I'm not going to make the renderer worry about that. What I am going to do is go to render front end. We do need a hook for this, right? So we have window render on resized. We also need I guess we can say void renderer on window created, right? Struct k window u16 width, u16 height. That's all we should really need to know as far as when a window is created. We should also know on window destroyed. And for that, all we need is the pointer to the window. Right? So we have initialize here. Then we have shutdown, and then resized here. So let's paste these guys here. And we'll say if window, because we can't really do anything else without it, right? We need to create a new window state and register it. We're also have a to-do. Create backend resources. So this is gonna be like IE Swapchain, etc. Actually, it's gonna be Swapchain frame buffers, etc. Okay. So the first thing we're gonna do here is we'll do a render window state. Window states. We'll start by zeroing that out. Oops. Window states. Window equals window. Window states. Frame buffer width equals width. Window states. Frame buffer height is height. Let's see what else. What else do we need? I think that might be active viewport. So I'm going to put a to-do or a fix me on that. Get or create active viewport. Which actually active viewport might not necessarily make any sense, right? We might just call it viewport. Called viewport. What was the other thing? Window states render target count. Right, and this is going to be a fix me as well. Required from the backend from the number of Swapchain images, right? So we got that. We have to make our backend entry point on creating a window. But once we have that created, then we can say darray push state pointer, or what was it? What was it again? I thought we had. Do we not have a state pointer? I thought we did. Did we get rid of that? Right there. Just put this here. So we'll say state pointer window states. Window state. Right, and so we'll say register the window state, right? Okay, so that's done. When we destroy a window, we're going to essentially have to undo this process, right? So we'll say, first off, if window. Let me clear the highlight because that's kind of annoying. Then we'll say, let's see, are we going to need to pass the window state to the back end? We might. We might. First thing I need is this. Right? And then we can say, let's do a to-do, simplify, get, process. And that's because I'm going to do some hackery here. So I'm going to do U32 window count equals darray length state pointer window states for U32 I equals 0, I is less than window counts plus plus I. And then if, actually let's do render window state equals address of state pointer window states sub I. And if window state window equals window, then we'll do a darray pop at. The array is going to be state pointer window states, index is going to be I, and we don't care about the value that we pop, so we're just going to do that, right? And what we'll do here is we'll say to-do, to-do destroy on backend first. All right, remove from the array, and then boot out, right? So yeah, the lookup process could be a little bit better, right? But for right now, that's only on a destroy, so I'm not really worried about the performance of that at the moment. On resize is going to be a little bit differently, right? So when we handle resize, we're actually going to have to do the same thing again. So I'm going to put to do here, and we're going to basically do most of this loop here, right? So so we have that. Right, and so if window state window is equal to window state frame buffer height equals height, and then window state frame buffer width equals width, and then we also need this guy here to do resize backend based on window, right? So we need to do that, and then we will return there. If we do not have a state pointer, which can be a thing, right? So if we haven't stood up the renderer backend, but the main window gets resized, that could be an issue. That issue is probably going to go away with this window refactoring. So I'm not really thinking it's going to be a long-term thing, but I'm gonna leave this logic in else otherwise, right? So to do may be able to remove this check if window in engine is created after renderer is stood up, right? So we could have forced that rule at the engine with this refactor. So that's another thing we can kind of clean up in the future, but we're not there yet. All right, so that's the resize. We should probably rename this, actually. Render on window resized. Okay. All right. So that should be that. We are going to have to handle that on the back end as well. So maybe I should just break the interface now so that we actually can't build completely until we fix that. Because we also need an entry point in the interface anyways. So let's go over here. Renderer types. Just don't name it IDR. Yeah, I suppose that's true, right? That's a good point. Let's see. I'm learning C++, Vulkan, and thinking about switching from Windows to Linux. Does it make sense to do this since I'm doing graphics programming? I've heard rumors that Windows is better for that, but I'm not sure. So here's the thing about that. If you are comfortable with Windows and you're trying to learn C++ and Vulkan, you're probably learning enough at once as is. You don't also then have to want to be learning your operating system on top of it. So if you've used Linux before and you're experienced enough with it and you're comfortable about doing that, then fine, switch. But if you're not, I would say stick to learning stick to learning Vulkan and C++ first, and then once you get more familiar with that, then maybe think about switching to Linux, right? I have my preference. I prefer working on Linux, but if you're learning something, try to minimize the number of things you're learning at once. Otherwise, you're just going to get confused and frustrated, right? Okay. So we need... Let me resize this a bit. So the backend interface needs a couple of changes. So we have this resized, right, which is what we're calling right now. This really should be window resized, right? And it should take the, should take the back end. It's going to take the struct k window, right? We haven't forward declared that, so we're gonna have to do that. I wonder if I can just do a how many times is plugin used here? It's literally used over 100 times. Great. Is it all literally used? Okay, so all of these are used within this context. So I'm actually just going to do a find and replace. So I'm going to say plugin, replace with backend. 138 substitutions on 138 lines. Glad I didn't do that manually. I should probably do that globally. 66 more. Perfect. All right. Let's see. So at least those things are named consistently, right? Let's see. So that's resize of render buffers. It's going to be above that. Texture resize. Window resized. Here we go. Handles window resizes. This is going to take window, a pointer to the window being resized. Right. And then at the top of this, we have a K window. Right. So that's our for declaration of our struct. So we have resize. We're going to need a create and a destroy for this as well. So the creates essentially looks the same interface wise as resized. So we'll do that one first. And so what I'm going to do is I'm actually just going to paste 2 copies of this guy. And we're going to rename this, right? So we're going to call this one window created. And this is going to be handles window creation. Okay, handle to the window being created. And we're going to say initial window width and initial window height, right? And then handles window destruction. And all we need for that is backend and the window itself, right? So we don't actually need, this guy, and we don't need this guy, right? And this is going to be renamed to window destroyed, right? So now at least, this is obviously going to break our plugin, but we knew that was going to happen anyway. So at least at this point, we can now say state pointer backend. Let's see, this is destroy window destroyed, right? And we're going to pass through the state pointer backend and the window. And let's see, why is this bleating? Oh, because backend is already a pointer. Right. Okay, so that's no longer a to-do. We now just have to implement that on the backend, but we'll find out about that anyways when we go to build. Okay, so we destroy that on the backend first. The creation will have to be done here as well. So I think it's safe to say that we can just call that function and we should be fine. Casson, thank you for the follow. Appreciate that. Oh, you know what? We should probably also do a B8 here to indicate whether the resource creation was successful or failed, right? So we'll do a returns true on success, otherwise false, right? on window created. Yeah, we should probably change this one too. Which is going to be need to be changed here. Right? If we fail on destruction of it, there's not really much we can do about that. And so I think that's fine. But if we fail on creation, that's something we should definitely know about. Okay. So before we register the window state, we should create backend resources, right? So we'll do that by calling state pointer. Oh, this needs to be moved up. Backend window created. Maybe we should rename that actually. This really should be window create and window destroy. Right? And so state pointer backend window with height. And we'll say that if that fails, let's bleat about it. Renderer backend failed to create resources for new window. See logs for details. Right, and then return false. Right, so we'll bleat about that. Otherwise, we'll push it here and return true. And up here, actually, if we don't have window, let's get rid of this guy. And say if we don't have window, renderer on window created requires a valid pointer to a window. Turn false. All right. Okay, so we'll create backend resources that we need for that. We are going to need the ability to either pass render target count to the front end on creation, or I'm not entirely convinced render target count is going to be per window, actually. I don't think it needs to be, now that I'm thinking about it. That should probably be a global thing. All windows should have like the same number of Swapchain images, same number of frames in flight, all that stuff. Ooh, which actually brings up another point. That actually brings up another point. This frame number here well, no, frame number should be the same always. Draw index theoretically could vary by window. Although I might do away with the thing that draw index was for to begin with. Because that was tied to queue submissions, which I don't necessarily want being exposed to the front end. So we might have to rethink that as well. Okay. diving deep on this one tonight, it seems. We're definitely going to have to move some more stuff around, but that's okay. Not a huge deal. Okay. So we've got our window stuff in place. I'm happy enough with that. You know what? All this state pointer plugin stuff, I'm gonna do a find and replace on that too, because that's kind of annoying. So we're gonna say state. Oops. Did I do? Oh yeah, I did. I did that wrong. State pointer. Plugin. And that needs to be state pointer backend. And we'll do that globally. It's 146 substitutions I'm glad I'm not doing by hand. All right, so a lot of this stuff is going to wind up, I think, staying the same, which is good. I guess let me try building this real fast and see what we run into. Okay, so engine has some issues. That I'm not surprised about because we changed our resize event, right? So let's fix that. Okay, so render on resized is here. Ooh. Cool. We just found another thing that I hadn't thought about. So, one thing that we did early on that I can now just say is a design decision I a little bit regret, but I guess it did simplify things at the time, is we have this notion of the engine state being running. Oh, suspended is another thing I'm going to have to think about. Ooh. Okay. So we have a notion of engine states running, which is the application running through its normal loop, right? That's fine. I don't think that's going to have to change. What is going to have to change is we have this concept of being suspended, which is normally what happens when you minimize the engine. It essentially just doesn't do any other stuff in this loop, right? So it just saves us from having to do a whole bunch of work. The problem with this is suspension was tied to minimizing a window, which isn't necessarily what we're going to want to do if we have multiple windows, right? Because theoretically, we're actually going to wind up, our loop's going to have to change quite a bit, actually. Because what we do right now is, if we're not suspended, we get the delta time, we update our timelines, our metrics, all that stuff, and then we check to see if we are resizing, which is a global property right now. It is not a property of each individual window, which it should be. And then we loop through. We say if we're resizing, how many frames has it been since the last resize event? If that's above 30 frames, then we say, okay, fire a renderer on resize event, right? Because we don't want to continuously fire that because that regenerates a whole bunch of resources under the hood. So we then do that. We call a frame prepare, which in this case, if we resized and then we call a frame prepare, we don't need to bother checking the result of it because that's going to trigger a swap chain creation And we're going to have to wait till the next frame to actually render anything anyway. Then we say to the game, go ahead and resize, which we should probably say that's the application, not the game, right? We probably should rename that as well. And then we reset the frame since resize counter and the resizing flag. Otherwise, we simulate a 60 FPS frame being drawn by sleeping for 16 milliseconds, right? And then we continue and try again on the next frame, right? So all the while we're resizing, we're trying to do this, right? So after we've done that, then we basically go through our frame prepare. Here's the problem. So our frame prepare is now actually going to be window specific, right? Because that directly can, well, I should say, can directly cause the Swapchain to be recreated, right? And the Swapchain is now tied to the window, as it should be. Okay, so we're going to have to do this per window. So frame prepare is going to have to be per window. And then I guess our game update doesn't have to be, right? That's just updating everything within the game or application itself. The renderer begin is going to have to be probably per frame as well, right? So the renderer begin. Debug label stuff is not going to have to be. Game inst render frame probably does not have to be. Although I suppose we could make that window specific. Renderer present is definitely window specific, right? Because that presents to the actual image that's tied to the surface that is the window, right? And then input update. So there are various aspects of this that are definitely tied to the window. And some aspects that can be, and then some things that definitely should not be. My thought is any of the renderer functions should probably be tied to the window. And then that also makes me think, we actually have, if we have more than one window, we may actually either require one queue per window if we have it, or if we don't have it, we're going to have to render a window and wait for that queue to complete before we can render the next window, which is kind of crappy. Right? And this is a bit of an exception case, right? Like multi-window is not going to be something we're going to do a lot of, but I think it's a non-zero number of amount that we're going to do with this, right? So it is something we're going to have to think about. Taman, how's it going? Good to see you. I've been in the zone. You're on a 14 stream streak. Nice. Appreciate the support there, buddy. So, to give you an overview of what we're doing, we've kind of gone down the rabbit hole again, but that's kind of to be expected with a refactor of this scale. So we've refactored, or we're in the middle of refactoring our renderer at the moment to take into account multiple windows. And the reason we're doing that is because our application config can technically define more than one, right? So we have this application config that we've set up that has some, global properties here, and then you have this array of windows that can be set up. Oops. You have this array of windows that can be set up. Right now we only have one, right? But we could theoretically have more than one. In the editor scenario, we're going to have more than one. And then the biggest portion of this is the systems configuration. the system's configuration. Each system can be configured in this file now. So we're porting all of our systems over to be configurable in this file. So the renderer, for example, is one of those systems. The plugin system is also where we're starting with this, right? So we have the name of the system here, and then its configuration follows after that, right? And so for our renderer, we have some global properties that we've sort of said, well, these are the initial things we're going to be starting off with now. So like vsync, power saving is true, enable validation, true, false, things like that. And then what the backend plugin name is, right? And so the backend plugin name is basically going to say, well, what renderer backend are we using? In this case, Vulkan. And that needs to match up with the plugin system's configuration with one of the plugins. They're named the same thing, right? And so we load a plugin system here that's called kohi plugin renderer Vulkan. Eventually with its config, and it's going to match up to this. The renderer can say, hey, plugin system, give me the plugin for this. And then initialize it, use the automatically loaded function pointers to do whatever initialization it needs to, get its hooks in, and then be able to go from there. And so we're kind of in the middle of that, but I was also kind of looking at converting some of our renderer functions over to take into account the window. So the renderer taking into account multiple windows is going to change our renderer architecture a little bit. And so, oh, there's your 15 stream streak. Awesome. Sweet. I love it. And so basically things like resources like our frame buffers and our swap chains are going to be a per window basis, right? Which now it's just kind of tied to the renderer instance as a one-to-one, and it's not necessarily always going to be a one-to-one. So now it needs to sort of have that tie to a window, which it really realistically should have had initially. And we've already extracted that out in the platform layer, and now we need to extract that out in the renderer layer. And so that, in addition to all of the configuration work that we're doing, is what we're working on right now. And then, of course, there's also converting our plugins to use the new plugin system way of doing things, so that everything kind of goes through the same entry points no matter what the plugin is. And that just will simplify the process of plugin development and also make it so that it's consistent. So I hope that makes sense. That's essentially what we're working on tonight. Quite a mouthful, I know. From Lake, you've been dropping in and out today. Yeah, I get that. This setup is what you've been looking for. Only 130 videos to go before you get there. Yeah. It's fine. It is what it is, right? I did put a warning in the beginning of this series that game engine dev is not for the faint of heart, right? I did put that in there. It's a lot of work. It's a very long process, right? Klingon, first time chat. Welcome to the stream. I'm doing well. How about you? Glad to have you here. All right. I feel like I might have missed an ad break. You're starting your renderer, Tammin, in your engine. Nice. Yeah, you did see the warning. Yep. Yeah, I made sure to start the series off saying that like 4 times. Like, this is not going to be like a quick 20 video tutorial series and then that's it, right? We're 3 years in. Having started on your own engine, you can already tell that it's going to be a long, long journey. Exactly. Yep. But it's such a satisfying journey as you get things in place and working, isn't it? It's super satisfying. All right. So how do I want to tackle this? I guess we can go to, we'll go to the renderer front end, and we'll add the window where it makes sense. We'll start with doing that. All right, so begin debug label doesn't really need it. Frame prepare. Frame prepare definitely needs it. Renderer begin, I feel like needs it. Renderer end, I feel like also needs it. Right, what window are we beginning and ending rendering to? And then present definitely needs it. That's probably render a viewport set and reset. Viewport and scissor. Those are just kind of injected at the time, like into the command buffer. So I think we probably don't need, none of that stuff needs windows added to it, I don't think. Stencil stuff definitely doesn't need it. Texture stuff doesn't require it. Texture read stuff doesn't require it. Render buffer get doesn't require it. Geometry stuff, that's all deprecated, so we don't need that stuff anymore. Render pass begin and end and all that stuff, I don't think any of that needs it. Or shader reloading, setting global, like I don't think any of this stuff needs it. I don't think anything beyond what we have already set is actually going to need to know about it. Oh, wait a minute. These two need to know about it. We have a couple of things here. Okay. So, render window attachment get. What window are we talking about? Depth attachment get. I feel like we're also going to have like a depth attachment per window. That may actually wind up changing per camera, but for now I'm going to keep it per window. Window attachment index get. Definitely need to know what window at this point. And attachment count get. We need to know that. Right? So we need both of those. This is all render buffer stuff. We don't need to do anything with that. Skip that. Okay. Active viewport sets. That might be the only other one. I'm not going to do that one just yet, but we might actually need to do that one too. Okay. So, let's see. That should pretty much do it. Let's go to front end C. And we're going to have to actually go back towards the top again, because there are a few things here that we're definitely going to have to change up. It's window creation. So here's frame prepare, right? So we need the window for that. So we'll do struct window. Render begin needs it. Render end needs it. Render present needs it. All right. Okay, so let's take a look at these first. All right. So attachment index. Yeah, our renderer interface is going to have to change too. All right, so window create, window destroy, frame prepare. Okay, so we're gonna have to add this stuff here too. Oh, all right. Struct k window. We have begin, so we'll add this here. We have end. Present. And then what were the other ones? I think it was they were towards the bottom, I think. Here we go. So it was a window attachment gets. Depth attachment get. And window attachment index. Yeah, I guess I'm gonna have to do. We do this. All right. Oh, of course it did it after though. All right. Okay. I think that's all the entry points. So when we come over here to front end, when we do, I think it was frame prepare was the first one we started looking at. Yeah, there's a couple things here. So, our P frame data is also going to have some stuff that's wrong. Okay. So, our renderer frame prepare, what this does is it reaches into the back end and it says, okay, what is your current image index, right? So in the case of triple buffering, it's going to say, okay, which image have we acquired from the presentation system to currently be able to render to, right? And Vulkan tells us that. I assume we'll have some equivalent in Metal and some equivalent in DirectX as well, right? DirectX 12. And so it tells us that. And I'm actually wondering if that's a detail that we should even be exposing outside the renderer, to be completely honest. Like, that should probably be saved off as part of the Windows state that's passed in, right? That we get when we say we're preparing for this window, right? We should probably say, well, okay, Ooh, and we're also incrementing the global frame number and the draw index here, which is not great. Okay, so I better start putting notes here on what we need to change. Because otherwise I'm going to lose track of it. So the frame number and draw index should not be globally updated here, but should be elsewhere. Maybe, so we have a frame prepare. Maybe we need a new renderer entry point, right? Like a renderer. What would we call that? So we have frame prepare. What would come before a frame prepare? You feel like a game engine is always something that will be work in progress, never finished. Yeah, I mean that's kind of true though, right? Like you'll have versions of it that you iterate on, for example. You had some not so fun pointer arithmetic bug on your D-array implementation. Yeah, I had some of those early on too. Those are not fun. But once you get those rock solid and write tests against it, then you're fine. I still find some bugs with stuff like that every once in a while, but most of that stuff is locked down tight at this point. But yes, they can definitely be very painful. Pointer bugs are always fun. Yeah, exactly. Depends on what your definition of fun is, right? All right, so renderer frame prepare. What could we do? What could we call that? Renderer. It's like a pre-prepare. I guess I'll put that for now. I'm not going to focus on it. Prepare. All right, naming. All right. So the frame number and draw index should not be globally updated here. The window attachment index and the window attachment index / render target index in frame data should be window specific. Actually, it must be. All right, and then the other thing is, do we really need to know the attachment render target index outside of the renderer? Probably not. Refactor anything relying on it. And I have a feeling that's going to touch the material system. I think that is mostly what's using it. Eliminate the above from frame data. Right? Because if we eliminate that from frame data, then we can't get it from anywhere, and we probably shouldn't be anyway. And then draw index, I don't... This is supposed to present queue submissions per frame. Do we need it? Okay. So the frame prepare, we put the backend, then we put the window, then p-frame data. That's fine. The attachment index gets, we need the backend state and the window. That's fine. We can at least fix those errors. Fix me. These probably shouldn't be here. And I'm putting notes in here so that I don't forget what all I need to actually fix, right? So I guess render begin is going to be kind of the same thing, right? So I guess render begin, we probably need to do like a deep dive on what all this stuff is doing. Window. But we'll fix the error for now, at least at this point. All right, so we do that. Again, though, this shouldn't be done here, or at least should be window specific. Right, and then we actually have two sources of truth, right? So fix me, eliminate this from frame data. I'd like to get rid of that draw index altogether, actually. And then this requires the window as well. Okay. So I think that is actually going to mostly fix. What is this bleating about? Oh. 818. What did we foobar over here? No, there's just a extraneous comma at the end here. Still not going to get to the point of building tonight, and that's okay. We're in the middle of a pretty massive refactor, so I'm good with that. Pre-prepare sounds like staging at my company. Yeah. Yeah, I mean, it's... Naming things sucks sometimes. Right? Like, I don't like pre-prepare either. I'm trying to think of a different name of it. Pre-prepare, yeah, right. Like maybe render frame prepare should just be called something else. And then we have another step before that that's actually called frame prepare. Right, because if we look at frame prepare here, move this up a little bit so you guys can see it. Essentially, all that frame prepare does is it says, okay, are we currently recreating the swap chain? Which actually, since that's going to be window specific, so this needs to be changed to have like a recreating swap chain per window, right? So that's going to be other changes we have to make. But it says, okay, well, if we are recreating the swap chain, then we wait for a little bit and say, okay, we're recreating the swap chain, and try again on the next frame. We then check the frame buffer size generation against the last generation, or to say, have we changed a render flag, like vsync, for example, anything that would require a swap chain regeneration. And we say, okay, well, if that's the case, then we need to recreate the swap chain and then boot. After setting that, this will continue to be true until the actual swap chain is recreated. And then after that, after the swap chain is recreated, or we're not recreating it and we're just kind of rendering as normal, we wait for the fence, acquire the next swap chain image from the presentation engine. And then once we do that, we double check to make sure that the swap chain isn't out of date. If it is, we just return false and move on. Then we reset the fence if none of that is needed. We clear the staging render buffer, right? And that's it, right? That's all that happens, right? So we acquire the next image from the swap chain, which is also what gives us our image index, which is ultimately what is the render target index here, right? So that is all that step does. So I'm thinking prepare might not be the best name for that there. We might rename this from prepare to something else. Render frame provision. That's not bad. Preamble. Frame prepare and frame post pair. Post pair. I like post pair. Let's just make up some words. I like that. I don't think post pair is a word, is it? It might not. Maybe I'm about to get schooled. Okay, the fact that the first thing that comes up on Google is an Urban Dictionary definition of it, I'm going to guess that that's not actually a word. And I'm not going to pull that up on stream because who knows what that contains. Frame peak staging and frame staging. Yeah, I don't hate that either. Provision is also not bad. Right? This is, I mean, you could say this is a provision, right? Theoretically. And actually, do we need, yeah, so we're going to increment the frame number no matter what, right? And that's really all that needs to happen in that step that happens before this, right? It's just something that needs to increment the frame number no matter what happens. But we want that to be like a separate process, I think. I suppose, I mean, because here's the thing, like, this could have multiple times it gets called, right? If you have 3 windows, it's going to get called 3 times in a certain frame. You don't want to increment the frame number 3 times, right? So we need something before that. I guess it would be, maybe it could be renderer prepare surface window, right? Like maybe that's what it is. Kuju raiding with a party of 22. Thank you so much for the raid. I appreciate that very much. What did you get up to on stream tonight? Welcome, raiders. You've caught me at an interesting time too, because I was actually winding down for the night. But I will give you guys an introduction as to what we're doing here. So, for those of you who are new, we are writing something called the Kohi game engine, which is a game engine built from scratch using C and Vulkan as our initial rendering backend. Kohi is a open source game engine that started off as a YouTube tutorial series, and now we stream it live on Twitch and YouTube. It is open source and it is royalty free, so it is all freely available on GitHub. We are currently in a feature branch, that's why this kind of looks old, but we are actively developing it. We're in our third year of development. So it's available here on GitHub. It is Apache 2.0 license, which basically means you can use it personally or commercially. It is totally fine. The only thing that I ask is that you say you used it. That's literally it. There will never be any sort of royalties or any sort of licensing fees of any kind. It's always going to be free and open source. It is cross-platform compatible, so it's available on Windows, Linux, and Mac OS. This is something that we're developing as a learning exercise. So this is not designed to compete with the likes of Unreal and Unity and things like that. But we are doing deep dives into various parts of game engine dev. So we do have a Discord with about 900 people on it. That number is continuously growing, right? So yeah, that is basically what we're doing here. And we're actually in the middle of a decently sized refactor where we are adding support for rendering to multiple windows, as well as having a very expressive application configuration file format that powers our plugin system and all kinds of other stuff along those lines. So let's see. You're working on implementing the new level from the artist finally. Oh, nice. Also in a custom game engine. Sweet. For your game Fat Goblins. That's awesome. Is it on Steam? Do you have a page up on Steam for that? Because if you do, I will go and wishlist it. So that's basically how our stuff's going. We are hopefully going to be starting on a game project somewhat here soon. We're actually trying to finish up what I'm calling version 0.7 of the engine right now. And basically, version 1.0 is going to come after we have built a game with it and released it. So the idea is that we're going to build like a really simple game with it first, and then we'll build something a little bit more complex to test out the features of the engine and sort of work all the bugs out of it and stuff like that. And then by the second or third game is when we'll probably batten down the hatches and start actually building things out like an editor and stuff like that. So yeah, that is more or less what we're doing. Like I said, though, I am getting ready to end the stream for tonight because I do have to get up in the morning and work. So, yeah, I appreciate the raid very much. Let me give you a shout out, actually. There we go. So if you aren't following Kuju, definitely go do that. I believe I am. I'm going to double check. Well, I am now. I thought I was. I could have swore that I was, but this is telling me I wasn't. So I'm definitely following you now. All right. So with all of that said, I'm going to go ahead and end the stream here for tonight. I really appreciate you guys being here and interacting with me both on the Twitch side and the YouTube side. It's been awesome. And we will be back tomorrow night for more of this refactor tractor work. Let me find a channel to raid. Actually, I think I already see who I'm going to raid. Let me just have a quick look. But yeah, I think I already see who I'm going to raid. Okay, so before I do that, I just want to say, if you guys haven't already, I would encourage you to follow me here or over on the YouTube side. It helps me grow the channel. The whole goal with this is to hopefully inspire people to get into game engine development and understand the technology that powers games. because we don't have enough engine developers out there these days. I feel like there's not enough people that are interested in the lower level of things, and I'm hoping that this is a way to get people into that. And so I'm trying to reach as many people as I can to hopefully increase the amount of folks out there with a little bit lower level knowledge that can contribute on this level. So that's my goal. And also, this is to sort of provide an educational resource, mainly one that I wish I had when I was trying to learn how to do this stuff. So if that sounds like something you want to join in on, follow along, support, I greatly appreciate the follows on either side or both sides if you're willing. So with that said, I'm going to go ahead and follow, or raid rather, Jitspo. So he is working on a pretty cool looking retro FPS. He's using Godot, but you know, it's a pretty neat looking engine, and he's actually integrated some decent tech in there of his own. So I think it's a really cool project, and definitely ask him about it when we get over there. But yeah, that's going to pretty much do it for tonight. Over there on the YouTube side, I will go ahead and drop a link to Jitspo's channel once we raid. But thank you guys so much for being here. I really appreciate it, and I will see you guys in the next stream. See ya.